Hey everyone, it's our last recording. This is the final exam review. And again, I'm only going to focus on the questions. That'll be like the ones that you're going to see on your final exam. And if you weren't in class to receive a copy of this review and you want one, you need to email me to ask for it. So let's start off by looking at simplifying using exponents, and the directions do state to make sure your answer is in correct form, which means you only have positive exponents. So our first one, we have the multiplication rule. Therefore, multiplying with the same bases, we'll add exponents. And so we'll combine our 9 plus 5 to get a new exponent of 14. So this first one is x to the 14th power. Here we have our division rule. Same bases means we can subtract our exponents. Remember, we're doing the top exponent minus the bottom exponent. And so we have 15 subtract 5 to get 10. So our final answer is x to the 10th power. Here we have our power raised to a power. And we saw in this type of problem, we multiply our exponents together. I put 6, and it's supposed to be 8. So we have x squared to the 8th power. So we will have 2 times 8, which gives us x to the 16th power. Here we have our idea of distributing that exponent. So we'll have 5 to the 0 power and y to the 0 power. And we also have here that anything to the 0 power is 1. So 5 to the 0 power is 1. Y to the 0 power is 1. And so 1 times 1 equals 1. Whereas this next problem, notice there's no parentheses. So this is 5 times y to the 0 power. So the 5 does not get the 0 power, so it stays as 5. Y to the 0 power does equal 1, so we have 5 times 1 in this case, which gives us our answer of 5. Again, we're multiplying, so we'll add exponents. We have 4 plus negative 11. And so our new exponent for our x is 4 to the negative 7th power. We're not allowed to keep our answer with a negative, so we have to take the reciprocal so we can use up that negative. So we'll have 1 over x to the 7th power as our final answer. Here's another division problem. And so we're subtracting. Remember, we're doing top exponent, subtract bottom exponent. So we have 2 subtract negative 7, which becomes 2 plus 7, which is positive 9. So we don't have to flip anything. And the last one we're going to look at is 8x to the negative 5th. So again, that's the same as 8 times x to the negative 5th. So notice that 8 does not have a negative exponent. It doesn't have to go anywhere. And since we can think of anything over 1, the 8 will stay in the numerator. And then the x to the 5th power will go in the denominator, so we can get rid of that negative with the 5. So 8 over x to the 5th power is that answer. And so let's use all these rules that we've been reviewing to do number 4. So we have 5a cubed times 2a to the negative 1 power, and that's all cubed. And then 5b cubed times 6b to the negative 2. So the first thing that we're going to do is get rid of our power raised to a power here and distribute. So on the top we'll have 4a cubed. And then we have 2 to the 3rd power, which is not 2 times 3. Remember, it's 2 times 2 times 2, which actually will give us 8. And we have a to the negative 3 power. All over 5b cubed times 6b to the negative 2 power. Okay, let's kind of look at this as two separate problems. Let's look at our top first. So we'll have our 4 times our 8 will go together. And then our a's will add exponents. We have 3, and we're adding negative 3. And so we get 8 times 4 is 32. And then 3 plus negative 3 is 0, so we have 0 a's left, or anything to the 0 power is 1, and 32 times 1 would be 32. So that's what our top simplifies down to, is 32. And then if we look at our bottom, we'll combine our 5 times our 6. And then for our b, we'll add 3 plus negative 2. And so 5 times 6 is 30. 3 plus negative 2 is 1. So we'll leave that 1 invisible and not write it. And so now all we need to do is simplify our answer. 32 and 30 are both even. So let's cut them in half, and that will give us 16 over 15. And we can't forget that we have a b in the denominator as well. So that's our final answer, 16 over 15b. Let's look at our scientific notation. Here we have a really small number. So remember, we're going to show that by times 10 to the negative power, because a small number is bad. And then we need to figure out how to get the decimal from where it is to where it needs to be, which is after our first non-zero, which is 8. And so let's count how many times we need to move it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So our 11 comes up with our negative sign. So 5 times 8 times 10 to the negative 11th power is that number in scientific notation. Now let's look at writing this number in decimal notation. This is positive, which positive is a good thing, and so is a large checkbook amount. So we're going to make it bigger. So we have 3.21. We need to move 6 spaces. So 2 spaces will give us after our number. So we need to add 4 zeros to be able to move that decimal back that far. So our final answer is 3, 2, 1, and then 4 zeros. And it's easier to read if we go through our commas. So 3,210,000 is our answer. Here's a story problem using our scientific notation. An atom of gold has a mass of approximately 3.25 times 10 to the negative 22 grams. What would be the mass of 8,000 atoms of gold? So first, 8,000 in scientific notation. We need to move that decimal in 3 times to get it to where the comma is. So that'll be 8 times 10 to the 3rd power. So to find out how much 8,000 weigh, we need to multiply. So we'll do our 3.25 times 10 to the negative 22 times 8 times 10 cubed. So remember, when we do this, we're going to multiply 3.25 times 8. And when we do that, we get 26. And our exponents we add together, so negative 22 plus 3. So when we go to simplify, 26 is not in proper scientific notation. So we need to move that decimal and make it smaller. But again, originally it was a larger, which is a good thing. So we will need to add 1 to our exponent to show that. And so our final answer will be 2.6 times 10 to the negative 18 power when we end up adding our negative 22 plus 3 plus 1. Next, we're going to look at some of our square roots. And if it's not a real number, it tells us to write that. Remember, no solution is not the proper answer for those. Round to nearest hundredth through number 100th is 2 decimal places. So if we put 56 under our square root in the calculator, it'll give us approximately 7.48 rounded 2 decimal places. For B, notice we have an addition underneath it, so we need to simplify that first. 10 plus 15 is 25. And 25 is a perfect square. It is 5 times 5. For C, we have a negative underneath our signs, so we have to look in here to see what our index is. We have an invisible 2, which is even. We can't take square roots of any even numbers. And so this is not a real number. And you'll deal with what it is in another class possibly. But I'm not going to tell you what the actual answer is here and confuse you. For E, we have the cube root of negative 343. So again, negative, but the 3 is odd, so we're okay. We can do that. And it takes negative 7 times itself 3 times to get you negative 343. Square root of 16 over 49. We're going to separate those and do the square root of 16 and the square root of 49 separate. The square root of 16 is 4. The square root of 49 is 7. So our answer is 4/7. Here's a story problem using our square roots. A square flower garden covers an area of 43 square feet. So what is the approximate length of each side? Remember that our area of a square is side squared. Our area in this problem is 43. So 43 equals side squared. So our side, I'll put over on this side, equals the square root of 43. Because to undo the square, we need to do the square root. And it tells us to round to the nearest tenth, which is 1 decimal place. So that's approximately 6.6, and we're in feet. Now we need to determine the amount of edging. Remember, edging is perimeter, distance around. So we have 4 sides that are all 6.6 feet long. So that gives us a perimeter of 26.4 feet, where it's not square feet, we're not back to area, it's just distance. And now we have $2.15 per foot times 26.4 feet of edging to make it without tax a cost of $56.76. Okay. Now let's kind of switch gears a little bit and look at our unit conversions. Again, you're going to have your chart available for you, so this is just a matter of finding the appropriate conversion. We're going pints to quarts, so that's US to US, and we start with 93 pints. Again, we want to get rid of pints, so that's going to go in the denominator of our unit fraction. We want to keep quarts, so that will go on the top. And it is 2 pints per 1 quart, so we can see we have to divide to get that. And half of 93 would be 46.5. The next one we're going to look at is inches to yards. And so again, we'll do 468 inches. Then set up the start of our unit fraction with inches on the bottom. the units we want to keep on the top, and it's 36 inches or 3 feet in 1 yard. And so we're dividing 468 by 36, and that gives us 13 yards long. Here we have 19 tons. The capital T is for the US tons, and it equals how many pounds? And so 19 tons. We want to get rid of tons and keep pounds. And the conversion is that 1 ton equals 2,000 pounds. So in this case, we get to multiply. 19 times 2,000 gives us 38,000 pounds. Now we have our metric to metric conversion. We have kilometers to centimeters. So again, think of your number line. Ooh, it's pretty bumpy there. Kilometers is here, then you have a couple, then you have your meters, then you have decimeter, here's your centimeter, and then we have our millimeter. So we're actually going 1, 2, 3, 4, 5 to get from the kilometers that they gave us to the centimeters that we need. So we need to move our decimal 5 spaces to the right. 1 space will get us after the 3, so we need to add 4 zeros to make 5 jumps. So 2, 5, 1, 3 with 4 zeros. And if we add our commas in there, you can see that equals 25,130,000 centimeters. This time we're going from liters to kilometers. So again, if you picture your number line, liters is in the middle, kilometers is all the way to the right. And so there's 2 in between. So it takes 1, 2, 3 spaces to the left to get from liters to kilometers. So we have to take that invisible decimal, we'll put it in there, and move it 1, 2, 3 spaces left. So that leaves us 0.745 kilometers. Now we're going from yards to millimeters. We don't have a conversion straight there, but we can do yards to meters first. So let's do that. So we have 1,000 yards. And again, we want to get rid of yards. So let's put that on the bottom. And we want to keep meters. And again, I like to keep it in multiplication. So I chose the conversion of 0.914 meters per 1 yard, which gives me 914 meters. Okay, and so then we have to change meters to millimeters. And so on our number line, meters is in the middle. We have deci, centi, and milli. So we're on 1, 2, 3 spaces right from meters to millimeters. So here's our invisible decimal after the 4. So that means we add 3 zeros to be able to make those 3 moves. And so we have 914,000 millimeters in 1,000 yards. For G, we're going from quarts to liters. And so 45 quarts. We want to get rid of quarts and keep liters. And again, I like to use the unit conversion where we multiply. So it's 0.946 liters per 1 quart. And when we multiply that, we get 42.57. If you want to use the other unit conversion, you can, and that would give you an answer of 42.45. Here we have pounds to grams. And so let's start off by looking at the unit conversion that we are given, and it's 150 pounds times our unit conversion, get rid of pounds. But instead of grams, our unit conversion is in kilograms, so we'll have to do a second unit conversion, moving that decimal. And again, the conversion is 1 pound to every 0.454 kilogram. And so that gives us 68.1, and that's in kilograms. And remember, kilograms to grams, we're going from left to right 3 spaces, so we need to move that decimal 3 spaces and add 2 zeros to be able to do that. So 68100. 68,100 grams and 150 pounds. Now let's look at a story problem. Juan works an 8-hour shift. How many minutes is that? So we know that there's 60 minutes in an hour. So let's just multiply it by our 60. And we get 480 minutes. Then we're looking at seconds. So we have a 480 minutes times 60 seconds in 1 minute. And that gives us 28,800 seconds. And so working 5 days a week, we would say we have 5 days times 20, 880, 28,800, I should say. And that gives us 144,000 seconds per week. Sounds more impressive than just 40 hours, doesn't it? Okay, another story problem. We have 4-pound bags for brown sugar, and we need to know how many ounces. And so let's do our 4 pounds. If you're not sure whether they're to multiply or divide, set up your unit fraction. 1 pound is equal to 16 ounces. So you can see we multiply, and that will give us 64 ounces. And so then it's asking us how many kilograms. We just use that one. So we have 4 pounds. We don't have to use the ounces. Let's go back to our pounds. Times 0.454 kilograms per 1 pound. And that gives us approximately, they didn't tell us how many decimal places to round, so I'll do 1.816 kilograms. And how many grams are there? So now we can use this one and then just move our decimal. So we have 1.861 kilograms. Remember, decimal moves 3 spaces to the right to go from kilograms to grams. And so our decimal will be all the way at the end. So we have 1816 or 1,816 grams in a 4-pound bag of brown sugar. Here we have our story problem dealing with our proportions that we've seen before. A nurse is told that a patient's IV is to run at a rate of 80 milliliters per hour. So as a fraction, we'll write that 80 milliliters per hour as 1 hour. And if a nurse uses a 215 milliliter bag of solution, we need to know how long that will last. So with cross multiplication, 80 goes with our x, and 1 times 215, we'll just put our 215 there. And so when we divide by 80 on both sides, we get x equals, if we round it to the nearest tenth, about 2.7 hours. Technically, it's 2.6875 hours. Here's a commission problem. A real estate agent works with 7% commission, and so the commission on a $165,000 house, we'll take our percent as a decimal, 0.07, and multiply it by the sale price of $165,000. And that's how much commission, so let's just put C equals for commission. So commission on that house is $11,550 when we multiply. Okay, let's look at a coupon next. You receive a coupon for 20% off any item at a local store. You decide to buy something that originally costs $63. So how much is a discount? So how much are they taking off? So they're taking off 20%, which is 0.20, times that $63 tells us that they're taking off $12.60. So it is a discounted price after you take that away. So it was $63 to start off with. And we're taking off the $12.60 discount. And that leaves us with a new price after the coupon of $50.40. So now we have to figure out sales tax. And so our sales tax as a decimal is 0.065. And we'll multiply that by the new price of $50.40. And rounding 2 decimal places, since it is money, we get that it's $3.28 in tax. And so the total amount of money that we'll spend is the $50.40 sale price plus $3.28 in tax, for a grand total of $53.68. Let's go to our geometry next. With question 20, we have the area of this figure, and this is a trapezoid area. According to the formula that you're allowed to look at for your sheet, is 1/2 times the base. Sorry, 1/2 times the height. Which should be the line drawn perpendicular to the bases, times your parallel sides of your parallel bases, they called A and B. So we have 1/2 times 5 times the sum of 6.8 and 10.2. So the area of the base is 1/2 of 5 would be 2.5. And when we add 6.8 plus 10.2, we get 17. And so the area, when we multiply the 2.5 times our 17, gives us 42.5. Don't forget your units of meters. And area means it's square units. So 42.5 square meters for our area. Our next question, we have our tool and die maker, Jerry, creating a steel cone that's solid. The cone is 4.5 inches tall, so that's our height. And a radius, good, they didn't give us a diameter, of 1.6. So how much steel will be used? This is volume because it's a solid steel. So volume equals, since it's a cone, we'll use the formula 1/3 pi r squared h. So we'll plug in our numbers. 1/3, we'll use 3.14 for pi. Our radius is 1.6. That gets squared times our height of 4.5. When we type all of that good stuff into the calculator, we get approximately 12.06 because it told us to round to the hundredth. And volume is in cubic units, so we have cubic inches. Here we have our ornament in the shape of a sphere or a ball, and we're putting it inside of a box with some soft foam pellets. The ornament has a diameter of 10. Let's scratch that out real quick and put a radius of 5. Divide it by 2 to get that radius. And a box whose cube, length times width times height, all the same, of 12 inches. So the volume of the ornament first, sphere is 4/3 times pi times radius cubed. So 4/3 times 3.14 times 5 cubed gives us a volume of 523.33 when we round to nearest hundredth. And again, it's in inches, so it's cubic inches. Our volume of the box, length times width times height, is all the same, so we can say that it's the side length 12 to the 3rd power. And that gives us 1728 cubic inches. And so the space that is left for the pellets will be our total space inside the box, 1728. Subtract the space taken up for our ornament, which is 523.33, which gives us a grand total of 1,204 and 67 hundredths cubic inches of foam pellets. Question 25, we're going to look at next. The billboard has a right triangle. Here's our right triangle billboard. And let's draw a smaller one for our scaled version. And in the scaled version, the base of the triangle is 3. And the height is 4. On the full size, the base is 72. And we need to know the height. So now that we see those measurements, let's set up our proportion. Our height is to 72 as 4 is to 3. So now we get to cross multiply. Our 3 times our h is the same amount as our 74 is times, 72 is times 4. And When we do that, we get 3H equals 288. And dividing by 3 tells us that the height of the billboard is 96 inches tall. Okay, next we're going to look at some probability. We have this data set and we need to find the range, the mode, the median, and the mean. So let's start by organizing our numbers from smallest to biggest so we can see those better. So we have 8, 8 again, 9, 11, 12, 14, and 15. So our range is the distance from the highest number 15, subtract the smallest number 8, excuse me, and that gives us 7. The mode is the number that's most often appearing in our list, and that is our double 8. The median is the middle number, and since we have 1, 2, 3, 4, 5, 6, 7, it will be a number that is there. So there'll be 3 on either side. So the fourth one is our median in the middle, which is 11. Our mean is our average. We add them all up. So 8 plus 8 plus 9 plus 11. So I'll just put sum here instead of writing all those numbers again. And we're dividing it by 7 total. And we add all those together. We get 77 as our total. So 77 divided by 7 gives us a mean or an average of 11 as well. Next, we're going to the Pizza Pie and Go. They sell about 620 pizzas each month. And so here's the breakdown of it. Notice that the onion, it does not have a percent next to it. So let's go ahead and figure that out. We'll take 100% and subtract off the others that we're given, 4, 37, 13, and 32. And that leaves us with 14% for our onion. And so just like before with percents, we just have to multiply our total times our percent to get what we have. Notice it says to round to the nearest integer. We're not going to sell partial pizzas. We don't sell them by the slice. We sell whole pizzas. And so for our ham, it's 0.04 as percent to decimal. And we have 620 pizzas, which gives you 24.8. So we'll round it to 25 pizzas. Our onion, we found that that's 14%, so 0.14 is a decimal, times our 620 pizzas, that gives us 86.8, so we'll round it to 87 pizzas. Our sausage, if we keep going around the circle, is 0.32 as a decimal, times 620 pizzas, and that'll give us 80.6, which rounds to 81 pizzas. Our mushroom, that would be my least favorite, and it gets 13% of the vote, so to speak. 13% of the pizza sold times 620 pizzas, which gives us 80. Ooh, I did the wrong number. Last one, I'll fix it. That was our 80.6, which is 81 pizzas. For my sausage, I read the numbers wrong on my paper. It was 198.4, so the sausage pizzas round to 198. Sorry about that. So it was the second favorite. The first favorite is pepperoni at 37%. And then if we multiply 0.37 times 620, we get 229.4, so we'll round that to 229 pizzas. Now let's look at an equation for 32. Excuse me, notice we have parentheses on both sides that we need to get rid of. So order of operation tells us to get rid of our parentheses first. So the 3 will get distributed on the left and the 7 on the right. So our -8 drops down. And then 3 times 4y will be 12y. 3 times -8 will be -24. And that equals 7 times 2y will be 14y. And 7 times -9 is -63. And then we have our +5. Next step is to combine like terms. By adding, we're not doing opposites yet because we're sticking on one side of the equation at a time. So we have -8 minus 24 more here. And so that will give us a -32. And we have plus 12y still. That didn't change. And that equals, there's only one y, so 14y stays. And -63 plus 5 will give us -58. Okay, so now we'll start moving things. And so we're going to zero out the y's on one side and the constants on the other. I like to move my smaller amount of y's to my larger. If not possible, I like to keep that positive. So we'll subtract 12y from both sides in order to get rid of all the y's on our left. So that means the constant needs to go left, so the -58. We have to do the opposite to add 58 to both sides. So that way all the constants zero out on the right. When we do that, we're left with -32 plus 58 on the left, which is 26. And on the right, 14 minus 12 is 2. So our final step is to divide both sides by 2. So we get 13 as our answer for y. Let's look at number 34. If 11 is added to a number, so here's our number, and we're adding 11 to it, the result is equals 45 less than, so remember less than means you're taking away from, so we'll leave ourselves some room, and then put our subtract 45, less than twice the number, so 2x is what we're subtracting from. So building the equation is what we translate. So x plus 11 equals 2x minus 45. Nothing to combine on either side, so let's go ahead and subtract our single x from both sides. So we'll move our x's to the right. And that means our 45 we need to zero out because it's not an x. So we'll plus 45 to both sides. So when we do that, our 45 zeroes out on the right. And on the left-hand side, 11 plus 45 is 56. And 2 minus 1 is 1, so 1x. We'll just keep that 1 invisible. We don't need to put it. And so there's our answer. There's nothing to divide on our last step. 56 equals our x. For 36, Andrew invests $38,500 per year in a bond that pays 3% and a stock that pays 9%. His total that he invested is $2,805. So how much was invested in each? Here we don't have a chart, so let's go ahead and create one. It makes it so much nicer. So we had a bond and a stock. Let's just put BS. Like that, don't you? And so the dollar amount we don't know. So let's say our bond is our P. So our stock fund was the total that we're allowed, $38,500 minus whatever that amount is, P. And then next comes our percent. So in our bond fund, that was 3%. So 0.03 as a decimal. And our stock is 9% interest, so 0.09. And so our last column is those previous two multiplied together. So we have 0.03p and 0.09 times the difference of 38,500 minus p. And remember, we're building our equation from this column, and we're told that the sum of that, the total yearly interest, was 2805. So when we go to build our equation, we have our 0.03p plus our 0.09 times the difference of 38,500 minus p, and that equals our $2,805 in interest. And we'll solve it from there. First thing to do is to get rid of our parentheses. So 0.03p stays the same for now. And we're adding to it 0.09 times 38,500 gives us 3,465. And we're subtracting from it 0.09 times p, so 0.09p. And that gives us 2805 again. Combining the like terms on the left gives us negative 0.06p. And we're still adding the 3465. And that equals 2805. After that, we need to subtract the 3465 from both sides because we need the p by itself. And so when we do that, let me just, I can type it. So I'll put minus 3465 here, and minus 3465 here. And so we get negative 0.06p equals negative 660. And we divide both sides by negative 0.06 to get p by itself. We get that that is $11,000. And remember, that's our bond. And so our stock is our total, our 38,500 minus 11,000, which gives us a total for our stock of $27,500. Okay, now we have our equation. It's in standard form, 3x minus 5y equals 15. And we're completing this chart to be able to have ordered pairs that are solutions to the equation. And so let's start off with -3. And -3 is our x value, so we'll do 3 times -3. And then minus 5y equals 15. So we'll simplify our multiplication and we get -9 minus 5y equals 15. We'll add 9 to both sides, and so that will give us -5y equals 24. And then divide both sides by -5, so that y is by by itself. And so y equals negative 24/5. And if you want to write it as a mixed number or decimal, that's fine. I'm just going to leave it as an improper fraction. Doesn't need simplified, so I'm good there. It's negative 24/5. Now we're plugging in 1, but this time it's a y value, so we'll do 3x minus 5 times 1 equals 15. And so 3x minus 5, when we do our multiplication, equals 15. To get rid of the minus 5, we'll add 5 to both sides. So 3x will equal 20 when we add 5. And our last step is divide by 3. So x equals 20/3. And again, it can't simplify, and I'm going to leave it as an improper fraction. Okay, for our zeros, our intercepts, first we'll do our y-intercept for x equals 0. So 3 times 0 minus 5y equals 0. Anything times 0 is 0, so I'm just going to cross that off and ignore it, because then I'm left with negative 5 equals, sorry, not equals 0, equals 15. Let me fix that. And so when we divide by negative 5, we see that our y value is negative 3. So 0, negative 3 for that ordered pair. And so now let's do our other 0, where we're plugging in 0 for y to get our x-intercept. So 3x minus 5 times 0 equals 15. So again, in this case, we're subtracting 0, so we'll just ignore it to simplify it. And then we have to divide both sides by 3 to get x by itself. And so x equals 5. So 5, 0 is our x-intercept. And the last one we need to do is plugging in 10 for x. So we'll have 3 times 10 minus 5y equals 15. 3 times 10 is 30. So 30 minus 5y equals 15. We subtract 30 from both sides, so we can zero that out and leave negative 5y on the left. And 15 minus 30 is negative 15. So then when we divide both sides by negative 5, we get y equals a positive 3. So 10, 3 is the final ordered pair. We're looking at 40 next. Y equals 3/4 x plus 2. First, it asks us the slope. This is in y equals mx plus b form, which is wonderful to answer these questions because our m value is our slope. And so the slope of the line is 3/4. And the y-intercept is our b value, which is 2, as an ordered pair, 0, 2. And so to graph it, I know on the paper it didn't give you a graph, but on your test it will. We're going to start at that y-intercept at 2. Our slope is 3/4, so we're going to count up 1, 2, 3 boxes since it's positive, and write 1, 2, 3, 4. And then do our best to connect those together. So there we go. And I'll add an arrow on this side since it doesn't have it. And there's your line. For this one, we are looking at the graph given and answering questions. Again, I know that sometimes the points don't look like they're perfectly on a number, but assume they are on the closest number that they are supposed to be on. And so the y-intercept, we'll look at the y-axis that's here. So that's at -2. Or if you want to write it as an ordered pair again, it would be 0, -2. It doesn't tell me I need it in an ordered pair, so -2 is fine. What is the slope? Well, they give us the x-intercept here, so let's count from one to the other. So we're counting down 2 boxes, so we'll put a -2 there, and write 1, 2, 3, 4, 5, 6. So we're going down to, right, 6 for our slope, and that can be simplified. And so we'll divide them each by 2, and we'll get -1/3. So again, that means that we could have gone down 1/3, which would have put us here to get the next point that crosses perfectly. But that's okay, we can simplify. So our equation in slope-intercept form, so y equals our slope, x, y-intercept. So it becomes y equals -1/3 x minus 2. Let's look at slope now in terms of our depreciation for our boat. Ryan bought a new boat for $27,500 in the year 2008. He knows that the value of the boat has appreciated linearly, and so we're using our x value as time equals 0, so 2008 is new. That means 0 years have passed. So brand new, or when 0 years have passed, the boat costs $27,500. So that's our ordered pair for the y-intercept. It's brand new. Now, in 2012, we have to look at time passed. So from 2008 to 2012, that is 4 years passed. So we'll use the x value, which again they are using as t, of 4 years. And the value now of the boat is $18,500. So our slope, our change in the y value, which is the change in the cost, we went from 27,500 down to 18,500. And we went from year 0 to year 4. So when we subtract the dollar amount, we get $9,000. And when we subtract the bottom, the years, we get -4, which is good because we need our slope to decrease in value, which means negative. So when we divide 9,000 by -4, we get -2,250. So the boat is depreciating by a rate of $2,250 per year. Now we're going to look at functions to determine if these given sets are a function, yes or no. And as I've mentioned before, we're looking for a repeat in the x's to determine whether it's a function. 5, 4, 2, 8. None of those repeat, so that's a function because there's no x value that's repeated with different y values. So here we have 4, 5, 4, 9. Our 4 is repeated, so here 4 is paired with 2, and then the second time 4 is paired with 3. So because of that, it's not a function. We can't have an x value paired with different y values. And then for our third one, we have 2, 3, 4, 6. So that one's trying to trick you by changing up the y values, which we're allowed to have repeating y values, just not x values. So this is still a function, yes. When we look at a graph to determine that, we can do our vertical line test because that's how we're checking those x values. So we can see on this, even if we check the y-axis, there's 1, 2, 3 points on this graph that have an x equals 0 value. So this is a definite no. Whereas this one, any place we check, we can only draw a line through one point on the graph. So that means no x values are repeated. So yes, it is a function. And the last question is evaluating using that function notation f of x. In this case is 3x squared minus 2x plus 8. And we're evaluating f of negative 5 and f of a. So remember, this replaces, let me actually write that with the typing so you can read it. It replaces x in the function. That's all it's doing. And so they're telling us to evaluate for x equals negative 5. And so we'll have 3 times negative 5 squared minus 2 times negative 5 plus 8. 3 times negative 5 squared is the same as 3 times 25 because negative 5 times negative 5 is 25. And so 3 times 25 will give us 75 there. And then negative 2 times negative 5 will give us a positive 10. And we'll copy the plus 8. And so 75, 85, 93 is our total for f of negative 5. Now for b, all they want us to do is replace our x with an a. So 3x squared becomes 3a squared minus 2x becomes minus 2a plus 8. So there's nothing else we can do because we don't have any specific numbers to plug in for that. Okay. Are you ready for your final exam? Is on the Files tab on Canvas. Great place to go next to make sure you're prepared for your final exam. Any questions, shoot me an email. Otherwise, good luck.